Okay, so today we're going to start calculating annuities. Remember the first lesson that we did in finance, and we did questions where, let's say you put an amount in the bank and you forget about it, right, for 10 years, and then you come back and you collect your money after 10 years, let's say, right? That money that you put in the bank, you're not touching. So you're accumulating interest over interest over interest, and then you're going to accumulate that money with your principal. You guys remember that, right?
Yeah.
Now, we're going to do almost the same thing, but this time, the money that you put in, you're not going to put it in all at one lump sum, okay? So you're going to make regular payment. This is what we call regular payment or regular deposit. So let's say every month or every year or every 2 weeks or whatever, you decide that you want to put into that account $100. Okay? Let's make it every month. So every month you want to go to the bank and put $100, right? What's happening is you're collecting money, you're collecting interest on the money that you're putting in, right? And at the same time you're putting extra money in. So every month you're going to have different amount of interest because you're adding that $100 every month. So we call this a regular payment, okay? So you see that now the formula is not only what we're used to with a bracket 1 plus I to the power of N or P, right? The formula becomes a little bit more complicated, okay? So we're still talking about compounding interest, so you're still earning interest on the interest, okay? But we're adding also to it the regular payment. So it's not a principal anymore, it's a regular payment that you are making every single time. So this is kind of similar to the scenario of house, right? When you buy a house, you do a regular payment, you do your regular monthly mortgage payment, right? So this is a similar scenario. Or when you purchase a car, right? Similar scenario. Okay. So we're going to look at the formula, and then we're going to look at examples, and then how can we now remember that the compounding period, we have annually, monthly, weekly, quarterly. So we're going to still have to do the same thing with the I and with the N. Remember that yesterday that we had to multiply N by your compounding period? I mean, not yesterday, a few days ago. And then you have to divide I by your compounding period. You guys remember that? Okay. So the compounding period, which is we call big N. So if it's annually, what would be big N?
1.
Semi-annually?
2.
Monthly? Semi-monthly? 24, because it's twice a month, right? Twice a month. Weekly. Weekly.
Weekly. 52.
Bi-weekly.
26.
Quarterly.
4.
And daily.
365.
Okay? So we're going to still use this big N to find small I and to find small n. Okay? So let's define the letters as well. So A is your future value. So this is, let's say if you go to the bank right now and you start depositing $100 every month for the next 10 years, right? So A is how much money you're going to have in the account after that time. So the amount or the future value. You might also see, instead of this formula, you might see FV equals to R 1 plus I to the power of N minus 1. In your formula sheet, you can also see instead of R, I think it's PMT, I think. Yeah, so they use PMT instead of R. Right? It's the same thing, it's the same idea. Okay? Same formula, same thing. PMT means R, your regular payment. A means your future R is your regular payment amount. I, how can I calculate I?
Begin. The percentage.
What do you divide the percentage divided by?
Compound.
Yeah, by the n, right? So remember that's your rate, but you change it to decimal, divided by your compounding period, right? And that would be your interest rate. And n is the number of compounding period. How can I find n?
And time of the year.
That's right. The number of years times big N.
Yeah.
Now, if they gave you the small n in month already, so let's say instead of giving you like in 2 years or whatever, they give you 36 months, okay? So, and then you're doing a monthly payment, you don't have to do that, right? Because it's already given to you in month, and you're looking for the monthly payment, okay? So sometimes you don't need to do the y times the n if they gave it to you in the same unit. Okay, so monthly, they gave you 36 months. Or weekly, they gave you 57 weeks. Okay, so they've already given it to you in the same unit. You don't have to. This formula can only be used if the payment interval is the same as the compounding period, and most, our questions in MAP 4C, it's going to be the same. So your compounding period is going to be the same as your regular payment. Okay? So if it's going to be monthly payment, then it's going to be compounded monthly. If it's going to be yearly payment, it's going to be compounded annually. If it's going to be weekly payment, it's going to be compounded weekly. So we're going to have the same units. Okay, so I don't need to. So, suppose $450 were deposited at the end of each quarter for 1.5 years into an annuity that earns 10% per compounding quarter. So remember that quarterly, right? This is what I was just saying about in the previous sentence. This is what I was just saying. Now what's happening here? What am I doing?
So A is the, R is the, R.
Why is it R? Why is it R? How do you decide that this is R?
It's the regular amount.
It's the regular payment. This is how you know that you have to use this formula, right? Because you're putting a regular payment. Otherwise, they would tell you a lump sum of $450 and you use the formulas from the previously learned, right? The formulas that we learned at the beginning. But in this case, you're gonna deposit $450 every 3 months, right? It's not gonna be only once. Yeah, quarterly means every 3 months. Quarterly, right? So 3 months, 3 months, 3 months gives you 12.
Yes.
Oh, okay.
Okay.
Just
So,
4 times a year.
remember that the letters that I have are I, R, I, and N. Right? So, suppose $450 were deposited at the end of each quarter for 1.5 years into an annuity that earns 10% per compounding quarterly. What is the amount of the annuity? So I don't know what the amount is, right? What's R?
400.
What's I?
I is. Go. What is the interest rate? It's a 0.10. 0.10.
Okay.
Divided by 4.
Divided by 4 because it's quarterly. right?
Yeah.
So what is that?
0.045.
0.025?
So in this case, interest rate you have to divide it by the n, which is the
The big N, yeah.
big n. Okay.
Yeah.
Okay.
Anytime that it's compounded other than annually, you're gonna have to divide by that period,
Okay.
compounded period. What's small n?
1.5 times 4.
Times 4.
Yeah.
So that's gonna be what?
6.
Okay? Now what we have to do is we have to take the formula. So the formula is A equals R. One plus I to the power of n minus 1 over I. Now, it's very important that you know how to use your calculator to do that. Okay? So, R is going to be 450. 1 plus 0.025 to the power of 6 minus 1. You see the brackets are very important. All divided by 0.025. Let's see who can get the correct answer from the first time. What do you get?
2,874. 40 cents. Times 40.
Okay, I put lots of brackets. That's why.
You probably want to start here.
That's why I started with
No. You want to start here? To the power of 6.
Good, same answer.
Everyone is fine.
the 1 plus 0.025.
Oh, we go.
You start with 1 plus 0.
1
Try it.
Okay.
Yeah.
Okay. And that's the top one?
Yeah. And
No. Close the bracket after the power of 6. Because you're doing 650, why 650?
Like this.
Yeah, you know.
Yeah.
Why? Minus 1.
You sure you got it? Are you dividing by 0.025?
Now I understand. So you have to go
Yeah, step by step.
step by step.
Bracket.
Reverse.
1 plus 0.025.
Right?
Bracket.
Reverse.
To the power of
Backwards,
6.
right? Pretty much.
Yeah, you do multiplication max.
Minus 1. When you find the answer, you multiply by 450.
$2,874.
Mm-hmm.
Try it again.
50 cents.
That's right.
So the amount at the end of my 1.5 years. question is, how much interest was actually earned? So how much interest did the annuity earn? How do you do that? Look at me and tell me what happened. What did we do here? What was the scenario? Just one 450?
No.
How
It
many
was quarterly.
450s?
It was quarterly, so it was 4 times.
So 450, 6 times.
6 times altogether, right? So he deposited 450 6 times. So how much is that? How much did he put from his own pocket?
2,700.
2,700. How much does he have actually in the account right now?
After all the multiplication.
2,800.
Yeah.
So how much interest did he earn?
Only
Oh.
100
Earn 147.48.
Yeah. So you see what I did? So you have to calculate how much money did he put from his own pocket, right? By multiplying the regular amount by how many times he put that regular amount in. And then you have to subtract the total value from that. Okay? So this is the formula, but I mean, even if you don't remember the formula, just remember what you're doing, right? So the interest rate, so he deposited, or she, I don't know what her name is, 450 times, 6 times, right?
Yeah.
So that is 2,700, right? The interest is equal to the amount that you have in the bank minus how much he deposited, which is equal to 174.48. Make sure you conclude with a therefore statement, right? I'm not gonna write it, but you guys should write it. Do you understand that?
I just have one question.
Yes.
Why 6 times?
Because you're looking at a year and a half,
Okay.
right?
Oh.
And then in a year and a half, quarterly, that's 6 times you deposit.
Got it.
Right?
Okay.